Welcome to your grade 12 Easy Spy YouTube stream. This is Yudesh, and we're starting a few minutes early. Just checking out my mic and everything else, just to make sure everything is in good health. Okay, it says the stream health is quite healthy, which is great. All right, so, and if you have any questions, please feel free to type into the chat. For some reason, there we go. Here's the chat. Hello. Just testing out the chat here. Feel free to ask questions. Okay, so what we're going to do is we are going to be talking about the remainder and the factor theorem today. And we're going to be covering a bit of theory, so this is going to be done in a slightly different way that we normally do the sessions, but that's okay. Right, so the remainder and factor theorem. We're going to talk a little bit about the remainder theorem, okay, and let's see what it states. But it states that the remainder theorem states that if a polynomial f of x is divided by a linear polynomial ax plus b, the remainder is f at minus b over a. Okay, now what you might notice from that is, how do I get that remainder? Well, sort of what's going on here is I'm essentially making ax plus b equal to 0, and then I'm solving for x, right? And if I get x is equal to minus b all over a, right? Because I took the b across and then I divided by a, I get minus b over a. Okay, so that's the remainder theorem. And so let's go to a quick example of the remainder theorem. Okay, they say use the remainder theorem to determine the remainder when you have f of x is equal to 4x cubed minus 8x squared plus x plus 2. Now you'll notice that this here function is a cubic function. Okay, and so let's say it's divided by x plus 4. So if I did this, the first, I would say, okay, I know x plus 4 is equal to 0. And then I would solve for x, and I say x is then equal to negative 4. And then what I would do is I'd take that negative 4 and I would plug it in. So I'd say, okay, let's work out f at negative 4. What does it mean? Wherever I see x, I replace it with negative 4. So this becomes 4 into minus 4 all cubed minus 8 into negative 4 all squared plus negative 4 plus 2. Okay, and of course, if you work this out correctly, just for the sake of speed, you get minus 386. Okay, so nothing too difficult about that. So this x minus 2 is pretty much the same. Let's take something a little more complicated. Let's say we take part D. And in part D, we say, okay, we start by saying 2x minus 5 is equal to 0. And therefore, I get x is equal to 5 over 2, right? And then I've got to work out f at 5 over 2. Okay, so I'm going to give you some time now to work that out, just to do a little bit of practice and make sure that you're getting some practice. I'll give you 2 minutes for that, and let's play a bit of stream beat here. Let's see, let's go to this and see what we get. Okay, let's stop it there. I think you don't need that much time. So what I'm going to do in this case is I'm going to, where I see x, I'm going to replace it with 5 over 2. So this then becomes 4 into 5 over 2 cubed minus 8 into 5 over 2 squared plus 5 over 2 plus 2. Okay, and of course you would probably use your calculator. You don't have to, but you end up with 17. Okay, so the answer here is 17. And this is essentially the remainder factor theorem. So let's go to something a bit more high level or level up. Right. Let's underline the key information. So in this case, when you have f of x is equal to 8x cubed plus ax squared plus bx plus 10, and it's divided by 2x minus 1, the remainder is 11. When f of x is divided by x plus 1, the remainder is negative 4. Determine the values of a and b as well as an equation of f. Now, what I'm going to do is I'm going to give you a start here, right? So we know the remainder is 11 when I'm dividing by 2x minus 1. So what I'm going to do is I'm going to start in this case by saying, okay, we know that 2x minus 1 is equal to 0, and therefore I get x, I take the 1 across, becomes 1, and I divide by 2, so x is equal to a half, right? So we now then know that f at a half, right? So where I see x, I'm going to replace it with a half, is 8 into a half cubed plus a, which I don't know, into a half squared plus b into a half, so b I don't know, plus 10, right? Now this is all what we had from the last example, and we know that the remainder is 11. Okay, so essentially that's one equation, right? What else do we know? Well, we know that f, and let's just do it again, right? But we got x plus 1 is equal to 0, therefore x must be equal to negative 1, right? The remainder is negative 4, so we can say that f at negative 1, and we can substitute, so we say 8 times negative 1 cubed plus 8 times negative 1 squared plus b times negative 1 plus 10. And what is that remainder? Well, that remainder is, sorry, this should be at 11. And this should be negative 4. Okay, so now what you're going to do is you're going to simplify this, and what you're going to notice is you might get two simultaneous equations, and then you're going to solve for a and b. Okay, I will take you through it, but first I'm going to give you some time to work through it. 2 minutes and go. All right, so let's have a look at completing this. So if you completed this, what you would have eventually had is you would have gotten something like this, right? You would have gotten 0 is equal to a over 4 plus b over 2, okay? And of course you could have then solved for a, right? You would have gotten a is equal to 2b, and that would have been your equation 1. And this is from the remainder when you had 2x minus 1. And then what you would have done is the same thing. So remember, we work out f at minus 1 is equal to minus 4. And then you would have gotten this equation. So minus 6 is equal to a minus b. But remember, we know a is minus 2b. So you would have then taken this and you would have substituted it right there. Right? And so you get minus 6 is equal to minus 2b minus b. And of course, in that case, you get b is equal to 2. And once you get b is equal to 2, you then take that and you substitute it in here. And that's how you get the a value, right? So now we have the values of a and b, which we can then plug in here, which save down here. So that becomes 8x cubed minus 4x squared plus 2x plus 10. Okay, and that is your answer, essentially. Okay, that's your answer. Just looking at my analytics here. Okay, so let's move on. And, okay, right. Okay, in this case, I'm going to take you through determine the remainder when f is divided by x plus 2x minus 1. Okay, so in this case, I would have said, okay, x, what are my critical values, or what am I going to be dividing by? Well, I'm going to be dividing by when x is minus 2 or when x is 1, right? If I work out f at minus 2, I then get minus 2 cubed minus 3 into minus 2 plus 2. Okay, now what does that give me? Minus cubed would be minus 8 plus 6 plus 8. So this gives me 0, right? And if I work out f at 1, what do I get? 1 cubed minus 3 times 1 plus 2, which also gives me 0, right? So both of these yield 0, right? That means there's no remainder. Okay, now if I go to the definition of a factor, the factor theorem also states that if f of x is a polynomial, much like this, and ax plus c is a factor, then f at minus a would be minus b over a is 0. Okay, so what does this tell me? This tells me when I'm getting 0 here, this would suggest that this and that are factors. Okay, because I'm getting 0. And that is the only difference between remainder and factor theorem. Okay, so now moving on, right? Well, there must be factors. That's the answer. And so now let's do something, right, with factors, right? So now they say, okay, if x plus 2 is a factor, right, of f of x is equal to 3x cubed plus px squared minus 2x plus 8, it's the value of p. Now, in this case, we know x is equal to negative 2, right? What else do we know? We know that f at negative 2, if I plug that in, that's going to be 3 into negative 2 cubed plus p into negative 2 squared minus 2 into negative 2 plus 8. And what do we know? Well, we know because this is a factor, it's going to be equal to 0. Okay, so let's just work this out. So negative 2 cubed is negative 8 times 3 is negative 24. Negative 2 squared is 4. 4 times p, so plus 4p. Negative 2 times negative 2 is plus 4. And plus 8. So I get minus 24 plus 4 is minus 20. Minus 20 plus 8 is minus 12. Remember, that's equal to 0. I take that across. I then get 4p is equal to 12, and therefore I get p must be equal to 3. Okay. And there we go. That's a nice, easy one about a factor. So let's level up. Okay. Now, here's an interesting one, right? Determine the values of a and b. If x squared plus x minus 2 is a factor of x cubed plus ax squared plus 2x plus b. Now, in this case, what you're going to do is you're going to say, okay, let's start with x squared plus x minus 2. And let's factorize it. Let's see if we can factorize it. Well, we can actually, because this can be factorized to be x minus 2, well, x plus 2 into x minus 1. Now, these are then the factors of this, right? And so in this case, we know that we can say, let's say we call this f of x, right? We know that in this case, if I plug in minus 2, so I can say, in this case, minus 2 cubed plus a times minus 2 squared plus 2 times minus 2 plus b. Now, what is that going to be equal to? Well, this is a factor, right? These are factors. That's going to be equal to 0. And then I also know that if I know that's going to be minus that's going to be x at f at 1, so I'm going to say, let me plug in 1. Same thing, 1 cubed plus a times 1 squared plus 2 times 1 plus b is equal to 0. Okay, I'm going to give you some time to solve this and see if you can get the value of a and b. It shouldn't take you too long. It should take you about 2 minutes. And go. And let's play some music. Alright, so let's just have a look at this one very quickly. Right, so we've set up the equation pretty nicely for you, but what you would notice is, right, so remember we said, okay, f at minus 2, right, remember we factorized this into x plus 2 and x minus 1. We then plugged it in, right, and eventually you will get, on the one side, well, you could say 4a plus b minus 12 is equal to b is equal to 0, and you would have also got a plus b plus 3 is equal to 0. So you could have made b the subject of the formula, so you would have done this equation 1, b is equal to minus 3 minus a, and then you could have plugged it in here, right, and then you could have solved for b or a, and then you would have gotten a is equal to 5 and b is equal to minus 8. So not too difficult, similar, just using simultaneous equations to do it. Okay, and so I think today what we're going to do is we're going to stop here. Alright, we will leave the factorization of cubic polynomials for the next episode. Thank you for those of you who joined, and I will see you next week, hopefully. Ciao. Ciao.